Okay, the indication that you want to use u-substitution here is that if you take the derivative of this, 2x to the fourth plus 8x, you get something that sort of looks like that. Not quite. We're missing a multiple of 2. If we could double this, we'd end up with 8x cubed plus 8. And so that's what we do over here. We think, well, I'm going to multiply this by 2 so that all of this will equal du, but I have to put a 1/2 out front to accommodate that fact. Now we're ready to use u-substitution. We're going to replace 2x to the fourth plus 8x with u, so I get u cubed. We're going to replace 8x cubed plus 8 with du. That's what du equals. And then we're ready to take the antiderivative of u cubed. Raise the exponent by 1, multiply by the reciprocal of the new exponent, evaluate that from -6 to 0 with a 1/2 out front. And by the way, here's where I determined how to replace the limits of integration. When x is -1, put -1 in for x and find out what the corresponding value of u is. Do the same for when x equals 0, you still get a 0. So here's the arithmetic. You get -162. I'll share my screen. We'll go to Desmos. And there's a kind of an indication of what's going on. There's f of x, a value only being displayed from -1 to 0. You can see that area is under the curve. So the definite integral from -1 to 0, I mean, it's under the x-axis. We would expect the result to be negative, and indeed it is. So this green region, which by the way goes way down here, I'm not even going to scroll all the way down, but that area is -162. Okay, hope that helps.